Other people might join us as we're going, but we'll get started with some of the housekeeping things, and feel free to let me know if you have any questions or comments. So my name is Abigail Jager. I'm a program manager here at Solar Oregon, and this is our Hallmark How to Go Solar and Storage presentation. In today's presentation, we are going to be covering how solar works, how you can know if your home is right for solar, before moving into the exciting topic of home energy storage. We'll then go through the various incentives available to you as a homeowner, and then look at how you can get started on your solar journey. First, really quick, a little bit about Solar Oregon. We are a nonprofit that has been around for the last 43 years, helping promote solar power throughout Oregon. We do presentations such as this one at least once a month in order to help arm home and business owners with all the knowledge they need in order to go solar themselves. We also do showcases and solar tours. We are a member-based nonprofit, and you can donate and become a member today at the link. Right now, I am going to stick a few links in the chat. This is just so you, I'll be referencing these links throughout our presentation today. And if you would like to access any of these resources later, please save them, as my email is also listed if you have any questions after the presentation. One of our upcoming events is our Zero Energy Home Tour. This is on October 14th, so just under 2 weeks away. It will be an exciting tour of 4 different sites in Northeast and Southeast Portland that all feature solar and other energy efficient features. It's a great place to talk with other homeowners and see what it would be like to go solar yourself. This presentation is sponsored by the Energy Trust of Oregon. The Energy Trust of Oregon is an independent nonprofit that helps provide access to affordable energy. Thank you, Energy Trust, for supporting this presentation. If at any point during the presentation you have any questions you'd like to ask, please use the Q&A function at the bottom of your screen. Feel free to put your questions in there at any time. You don't have to wait for the end. You can also put comments in there. That is how we will be doing a Q&A at the end of the presentation. Now, really quickly, before we get into the presentation, I'm going to launch a few different polls just so we can see who's in the Zoom room today. Okay, that's the first one. Here's the next one. All of these polls are confidential and anonymous and are just for our own internal record keeping, and they are completely optional as well. Okay, and one more poll. This one's just 2 questions. Awesome, thank you so much for doing that. So now, without further ado, let's get into the presentation, and we'll begin by discussing how solar works. So here's a very simple diagram of the different components of your solar system, and we're going to be going through this one by one. So first up, right here on the topmost left side is the photovoltaic or PV panel. This is the solar panel that would either be on your roof or in the ground around your home, and this is what generates the volt of electricity when the sunlight hits it. You're probably familiar from seeing these either in solar farms or on your friends and neighbors' homes. From there, once the volt of electricity is generated, that is generated in DC or direct current electricity, which is different from the electricity that your home runs on. In order to convert the DC electricity that is generated by the panel into usable energy for your home, it goes through an inverter or microinverter, which we'll be discussing in more detail on a later slide. This is just a special device that converts that electricity from DC or direct current electricity to AC or alternate current electricity. From there, it goes into your home electrical panel, where it helps to power everything in your home, from your lights, appliances, to charging an electric vehicle. If at any given point in time you are generating more power than your home is using, then the excess energy flows out to the utility meter and the utility grid in order to be used by your friends and neighbors. Conversely, if at any point you are not generating as much electricity as you need, such as at night when the sun isn't shining, then power can flow from your utility grid into your utility meter and back into your home. This is called a grid-tied solar system and would be different than someone who would say in a cabin off in the woods completely off-grid. So now we're going to look through some of those components I mentioned in a little more detail, starting with the inverter. So as I said, there are two different types of inverters. Both are installed frequently throughout Oregon and really just depend on the specific needs of your specific system. First here on the left, we have a string inverter, which is this white box that takes in all the power from all the panels at once and converts it into AC electricity all at once. This is usually installed right next to your breaker box, so it can be installed on the outside of your home as pictured here. Another option are microinverters as pictured on the right. And in this image, we're actually looking up at the back side of the solar panels. So the microinverters are actually mounted there. And instead of taking in all the electricity from all the solar panels at once, they take in only the electricity from one or two panels. So if you have 10 solar panels, you could have up to 10 microinverters. This allows for some more parsing, as if one solar panel is shaded but others are not, those solar panels that are not shaded can still be generating electricity. As I said, all of these are really great options that are installed frequently throughout Oregon. It really just depends on the need of your specific system. Solar systems are highly modular and very customizable, so you will have an in-depth conversation with your solar contractor about which of these options is right for you. Now, there are two different ways your solar panels can actually be mounted in order to be used. The most common in dense urban areas like Portland are roof mounts. This is when your solar panel is mounted on your roof. The other option is ground mounting, as pictured here on the right, and that's when your solar panels are mounted on posts in cement in the ground. This is more common in those big solar farms that you might see, like driving out to Mount Hood or up the gorge, or down to Southern Oregon, or in just areas that have a little bit more space that they can dedicate to solar. There can be some added costs with ground mounting, as you do have to run conduit lines from those solar panels out in the ground back to your home. Now, another option are solar roof tiles. This is both a solar and roofing product. So your roof tiles both protect your home from wind, rain, snow, and other elements, and generate solar power. There are several brands available. However, because this is a much newer technology, it is also much more expensive. Price declines have been predicted for quite some time. However, none have quite come to fruition yet. So if you are thinking you might want this, you could be waiting for an indeterminate amount of time if you're waiting for a price decline. If you are interested in getting solar roof tiles, make sure you have a contractor who has installed them before, as the product is a bit more complicated than a normal solar panel, as you are also installing a new roof. You want to be sure your home is both being protected by this product and generating the solar that it is needed. But it is a great option if you're up for the price point. Now, as I mentioned, we're mostly discussing grid-tied solar systems here. And the way grid-tied solar systems save you money is through a process called net metering. In order to explain how net metering works, we're going to go through two case studies here of both a typical sunny summer month and a typical cloudy winter month. And then we'll be looking at an example energy bill. So, as I said, in a typical sunny summer month, your solar panels are generating all the solar, they are generating a ton of power, and at any given point in time, you might be generating more than you're using. This goes out back to the grid to be used by your neighbors. Because of that, as power is exported back to the grid, you will be earning net metering credits. So your consumption is shown in the blue bar here, and your solar production is shown in the orange bar on the left. Your net metering credits that you're earning is then the difference between those two bars. This is what happens during the typical sunny summer months, as I said. And then during the typical cloudy winter months, so like right now, if you have solar panels, they wouldn't be generating too much. It's pretty overcast today, at least where I'm sitting. And so while your consumption has stayed about the same, the amount of solar your panels are producing, while not zero, is less than you are consuming. That means you're having to draw more power from the grid. But rather than having to pay for that power at the normal market rates, as you're doing now if you don't have solar, you instead will be using up those net metering credits that you earn throughout the sunny summer months, as those credits do roll over from month to month. It is important to note, though, that your net metering credits do not roll over from year to year. That means you build up your credits all summer long, and then they deplete throughout the winter. The net metering year begins and ends on April 1st, so any credits that you have left over at the end of March 31st are forfeited and donated to low-income families. So that is the basics of how net metering works. In order to explain it in a little bit more depth, we're now going to look at a typical power bill. So here on this bill, we can see the meter reading at both the beginning and at the end of the month, as well as the net period usage. When we look at that number, we can see that's in the negative, meaning 327 kilowatt hours were banked as excess credit that was generated. This is then added to that year-to-date banked excess generation, and the billable kilowatt hours for this period is 0 kilowatt hours. That's because this is a typical sunny summer month, and all the power is just going. You're generating way more than you need, so even if you are having to draw some from the grid like at night, it is fully offset and you have 0 billable kilowatt hours. Now, if we do look over at this box on the right, we can see that despite having 0 billable kilowatt hours, your bill is not 0. That's because you have about an $11 charge in order to just be connected to the grid in the first place. And then this customer was in city of Portland and Multnomah County, and so they have about $1.63 in taxes and fees that are added on. So with that, it comes out to a total of $12.63. However, while this bill is not 0, it is still a really great savings, especially when you consider the fact that the average Oregon utility bill is about $70, and that average is rising every year as the price of power goes up. So that is the basics of how net metering works and how you're able to use your solar system to help save you money. So now, as I mentioned, your net metering credits generated by your solar system roll over from month to month. However, they do not roll over from year to year. Because of that, you really want to size your system based on how much electricity you consume, as you want to meet but not exceed your annual consumption. Other factors that might impact the size of your system are available space, budget, and aesthetics. Solar system is measured in kilowatts, and the average size here in Oregon is about 8 kilowatts. It will be a discussion with your solar contractor if you can fit 8 kilowatts or bigger or smaller on your roof based on how much you need. As I said, you really don't want to be paying for more electricity than you need, and that also means it's important to discuss any major life changes with your solar contractor. So if you're anticipating anyone moving in or out of your home or switching to electric appliances, as all of those would impact your annual consumption. So now, how do you know if your home is right for solar? So no matter where you are in the state, you do have enough solar access. Here we can see the arc of the sun at both the summer solstice, so when it is highest in the sky, and the winter solstice when it's at the lowest. At any given point in time, it will be between those two arcs, meaning as long as you have a south, east, or west, or any combination of those three facing roof, you can get solar. The only roof plane that solar is typically not installed on are north, northeast, and northwest roof planes. One thing that can impact your solar access is if you have a very shaded home. Solar panels obviously need sun, so if your home is shaded for most of the day, don't cut down those really big trees, as they can be a really great resource and do help keep your home cool. However, you might not be the best candidate for solar, and you might want to look into other options such as community solar instead. And I did put a link for that in the chat below, and you can also check out the Oregon Clean Power Co-op's website for more information on community solar as well. They're a great resource. Another thing that can impact your solar is roof complexity. Here on the left, we can see a really complex roof. So while there are many south-facing roof planes, you couldn't actually get that big of an array because they're all facing different directions and they're all pretty small planes overall. However, here on the right, we can see a very simple roof, and we can see how one large solar array that's very simple could be added in. This would overall be cheaper because you're not having to add the complexity of multiple roof planes for your contractor to figure out and size your system accordingly. The other thing to consider is your roof condition and age. We recommend that you have 20 plus years of life on your roof, as in order to replace your roof once you have solar on, you have to take off your solar panels and then put them back on, which just is an added cost up to $10,000 on average. This can also damage your solar panels and you might end up needing to replace some of them. So if you have an old roof, we recommend you wait to get solar until after you re-roof your home. Another part of your roof that can impact your ability to go solar are what supports are under your roof. Solar obviously adds a little bit of weight on top of your roof. So depending on what those supports are, you might have to do some extra engineering with your solar contractor and possibly even adding in more supports in order to support the weight of solar. If you have trusses, like pictured here on the left, you can support even the most strictest roof laws as they pertain to solar. However, if you just have rafters, as very common in many of the older homes here in the Portland, Oregon area, you might not be able to support them. And again, just might incur some extra cost of having to add those supports and also having an engineer draw out some diagrams in order to see if your rafters can support a solar system. So now let's move into the exciting topic of solar and storage. Excuse me. So solar makes storage more effective. Without energy storage, you cannot use your solar panels during a blackout in order to protect anyone working on the power line. However, if you have storage, they are complementary technologies. So your solar can help charge your home's battery system, and your home battery system allows you to access your power during a blackout. Here's just a quick example. So you can have batteries in the garage, which would be your storage, and your solar on your roof helping charge it. So now, why would you want to have energy resilience? And energy resilience is the ability to use power when the grid is down. Frequent short outages are usually caused by storms or squirrels. Other short outages might be a public safety power shutoff in order to decrease fire danger. The first of these power safety shutoffs occurred in Oregon in 2020, and that is when the power company actually shuts down the grid in order to decrease the fire hazard. Another reason you might want energy resilience is in preparation for the Cascadia seismic hazard. This is the predicted earthquake that is said to be coming for this region. And in the Portland area, it's said that we might not have power for up to 6 weeks, and it could be much longer out on the coast. So when picking a battery, there are many brands and chemistries available. Installers, however, may specialize in one battery in particular. So if you have one you would want to be sure that your installer is familiar with that battery and is comfortable installing it. One important thing to remember is that you cannot mix and match batteries. You can mix and match batteries in solar system installers, however, or companies, non-installers, apologies. But if you have, let's say, a Tesla Powerwall battery, you cannot then add on an ion battery on top of that. You have to stick with the same brand that you originally went with. If you are powering a motor, you also do want to be aware of your battery surge capacity in order to not overload it. So now when thinking about getting a battery, it's important to set your expectations. And backing up your entire home on a singular battery, or on batteries for a meaningful length of time can be prohibitively expensive. So it's really important to set your expectations about how long your battery will last. What's really common to do is a partial home backup where you select only a few outlets or areas in order to receive power in the event of an outage. This is done through the creation of an essential loads panel, where breakers are moved to a new additional panel, and in the event of an outage, the power is then routed. All your other breakers will switch off, and only your essential loads panel stays on. This does add complexity and cost, but it can be a really great solution. When thinking about what you would want to put on an essential loads panel, it's a question of what needs power and for how long. Things commonly chosen to back up are a refrigerator, some lights, and maybe an outlet or two for charging. The fewer things you have on your battery, obviously, the longer it'll last, but it's really a question of what you need and for how long you want to try and keep it. And you can also be very minimal with the power you're using during an outage if you're anticipating it to be quite a long time. If it is sunny enough, your solar panels can also recharge your battery. Of course, if you're out of power because of a snowstorm, that might not happen. So now when to install storage. There are two different types of storage, both AC coupled and DC coupled storage. If you install solar and storage at the same time, it can save you money because you'll be able to access more incentives. Storage can be added to an existing solar system, but there are some incentives you're not able to access if you're adding just storage to an existing system. And so it's important to keep that in mind. The AC coupled versus DC coupled really just depends on your system configuration. And if you already have a solar system, it can be not an option to put in a certain type of battery and due to space limitations. And so you might be limited in your battery options. One important thing to note is that batteries require space. Near an electrical panel is best, and they cannot be within a crawl space, cupboard, or other enclosed area due to the National Electrical Code. An outdoor install can be okay, but you may not be most desirable due to aesthetics. So now let's go through the possible incentives you'd be able to access if you're interested in getting solar storage for yourself. So the biggest incentive available to you is the Solar Investment Tax Credit. This is a 30% dollar for dollar total cost of your system that you get back on your next year's taxes as a direct reimbursement. Really quickly, I am not a tax professional. Please talk to a tax professional, and this is not official tax advice, but here's some quick details about the investment tax credit. As I said, this is a 30% dollar for dollar incentive. So if your system was $1,000, this would be a $300 check on your taxes. It can be applied to both solar and storage, and if you do not have enough tax liability to claim it, it can be claimed over several years. There are many myths about what can be claimed on this tax credit. One common misconception is that regrouping costs can be claimed. However, this is not true. If you have more questions about the investment tax credit, I highly recommend speaking to a tax professional. Another great incentive are the incentives offered through the Energy Trust of Oregon. Energy Trust of Oregon offers $400 for PGE customers and $450 for Pacific Power customers. And they recently launched their new storage incentive, which is $250 per kilowatt hour added in storage, up to $3,000 maximum per home for energy storage. In order to access these incentives, you do have to use an Energy Trust of Oregon Trade Ally contractor, which we recommend using anyway, and I'll be going through some details on how to find a Trade Ally contractor at the end of this presentation. Another great Energy Trust of Oregon incentive is their Solar Within Reach program. This is a program specifically for low and moderate income folks and offers just a higher incentive for installing storage and solar and energy storage. The household for income threshold is very generous at $112,860. So you might be able to qualify for it, and it's a great one to check out. The next incentive is the Solar and Storage Rebate Program, and this incentive is currently in a bit of a transitionary period. So if you are just starting your solar journey, some of this stuff may change by the time you're ready to sign with a contractor, but here are some details on the Solar and Storage Rebate. This is offered through the Oregon Department of Energy and is up to $5,000 max for solar and $2,500 for storage that is installed at the same time as solar. So if you already have a solar system, you are not able to access this incentive for added storage. Currently, it was just recent. Currently, the only funds remaining are for low and moderate income folks. The income threshold is different than the Solar Within Reach incentive, so you might qualify for one and not the other, and it's a great thing to check out. For non-low and moderate income folks, this program was just refunded by the Oregon legislature, yay. However, those funds have not yet been released, and they're going to be changing some of the thresholds and maximums for non-LMI folks. So please keep a lookout for when those funds are released, as it'll be a great option, but currently they're not yet available. So now, next I'm going to be going through a few different budgets so you can try and get a sense of how solar works and how much a system of solar and storage might cost you. However, it's very important to note that solar systems are highly modular. This means that while these budgets are examples, your system could be a very different price, either more or less, depending on your specific needs. Reasons costs may vary for solar can be the size of your system, if you need regrouping, any structural analysis that is needed, and how many incentives you can access. The same thing goes for storage. Costs can vary depending on if you're installing them in conjunction with the solar system or later, how many batteries you're installing, whether you're moving some outlets to an essential loads panel, how far you're installing batteries from the electrical panel, and again, how many incentives you can access. So now for everyone's favorite part, let's look at how much a solar system would cost you. So the cost before any incentives for just a basic 8 kilowatt solar system is about $32,000. You can then access the Energy Trust incentive, and as those state rebate funds for non-LMI folks have not yet been released, we are discounting that as a zero for right now. However, both the Solar Within Reach and state incentive funds are listed here in the far rightmost two columns. Once these incentives are taken out, you're then left with a cost of about $31,500 for non-LMI folks and about $21,000 for LMI folks. From there, you can then take out your 30% federal tax credit that you would get, which decreases your cost by just under $10,000 for non-LMI households and just over $6,000 for LMI folks, bringing your total cost to about $22,000 or about $15,000 if for LMI folks. Now, if you also want to get storage and you're installing both your solar and storage together at the same time, your cost before incentives is about $44,000 total for both your 8 kilowatt solar system and 10 kilowatt hour storage. You then can access both Energy Trust of Oregon incentives, so both their solar incentive and their storage incentive. And for LMI folks, if you're accessing Solar Within Reach and the state rebates, you get all of those discounts as well. That takes your out-of-pocket cost to about $41,000 for non-LMI and about $24,000 for LMI households. From there, again, you can claim that 30% federal tax credit and bring your total cost down to about $28,000 for non-LMI households and about $17,000 for LMI households. Lastly, this last budget just shows how much it can be to add to get solar, and then a few years later, add storage. So you're not adding solar and storage at the same time. Your cost of solar, that 8 kilowatt solar system, stays about the same at $32,000. However, the cost of adding a battery after you've already installed your solar system is an additional $23,000. This is more expensive than that $44,000 on the last slide, just because you have to get all the workers back out and redraw permits and things like that. The Energy Trust of Oregon incentives, you can access both of those, assuming you have a trade ally contractor. However, you are only able to access the solar incentive from the state rebate and not access that storage incentive, as it requires you to get solar and storage at the same time. Your out-of-pocket cost is then listed, and again, you can then take your 30% federal tax credit, taking your final cost to about $36,400, or about $26,600 if you are an LMI household. So now, those are some very big numbers, and it's okay to have some sticker shock. Financing is very common. There are some loans specifically tailored to solar that allow you to refinance your loan after you claim that federal tax credit. And your installer may have a financing partner, or you can talk to your bank or local credit union. Now, with all this great information, how do you get started on getting a solar system of your very own? As I mentioned, we highly recommend you work with the Energy Trust of Oregon Trade Allies. These are rigorously qualified solar contractors that have been able to meet and exceed Energy Trust of Oregon standards in order to get their certification. They are familiar with all Energy Trust design and installation requirements and are able to allow you to access those Energy Trust of Oregon Trade Ally incentives. These are great contractors and can be a really great resource. In order to access those contractors, we recommend using the Energy Trust of Oregon custom analysis and bid tool. This allows you to put in some details about your home and provide you with a customized bid from up to three highly rated solar contractors that work in your area, in order to just get you 3 quotes right off the bat, which we recommend doing anyway in order to make sure you are getting the best work possible. From there, contractors will complete all necessary paperwork for you to access any incentives you are applying for, except for your solar tax credit. So this means they would apply for and receive the Energy Trust of Oregon incentive on your behalf and the state rebate on your behalf. However, you are responsible for applying and receiving the federal tax credit. Permitting is still experiencing some delays in the Portland area. I know permitting can take about 10 months right now. However, once you get those permits done and approved, installation is very quick at only 1 or 2 days. And your contractor will manage all inspections and interconnections in order to ensure that you are ready to go and connected to the grid. From there, you'll begin getting your net metering credits and saving money. So now feel free to stick any questions you have in the chat. There is the Q&A right there. And I'm also going to launch one last poll while people are thinking of their questions. Well, if no one has any questions, I'm going to stick those links in the chat just one more time. If anything comes up, please feel free to send me an email. I'm more than happy to answer any questions you have offline. And thank you so much for coming today.